Good day, this is SciPi, and today we're going to talk about cross multiplication. We're going to be using the fraction strategies that we had learned in a previous video. So fractions can really be difficult, but we need to think about clarifying and reducing them when we're doing cross multiplication. So the purpose of cross multiplication is to clear the fractions and rewrite the equation. What do I mean by that? Well, let's look at a sample problem. 4 over 3x equals 2 over 9. So the first thing I want to do is see, can I reduce? No. All right. Now I could find the lowest common denominator, which would be 3x times 9, or 27x. And that means I would multiply both of these by 9, and I would multiply both of these by 3x. That would work because I would get 36 over 27x equals 6x over 27x, and then I could cross out my denominators because they're the same, and then solve. So 36 equals 6x, and I can divide both by 6, so x is 6. But today we're going to try cross multiplication. Again, remember, it's to clear the fractions and rewrite the equation. It only works when you have one fraction on this side and one fraction on this side. So now let's do the same problem using our cross multiplication. What that means is I'm going to cross multiply across the equal sign. So I'm going to go 3x times 2. And I always like to do my x first. Most students are more comfortable with the x's on the left-hand side, although, as you saw before, they can be on the right-hand side. But I always tell them, try to do the x first. So if I go 3x times 2, I get 6x. And then if I do 9 times 4, I get 36. Notice where I am compared to the previous problem. I'm almost done. So when I divide both by 6, I get the same answer as x is 6. So cross multiplication is to multiply across the equal sign when there's one fraction on both sides. All right, let's continue using cross multiplication, and let's look at this problem, which you can see is a little more complex because now I have 2 terms up here and 2 terms up here. Again, I could find the common denominator and multiply by that. But now, let's just use our cross multiplication. Oh, I got a y on both sides. So I'm going to just figure, well, I'll do this. 2 times 4y is 8y, and 2 times 4 is 8 equals, and then 3 times y is 3y, and 3 times plus 1 is 3. Then I'm going to clear, and let's clear the 8. By doing the inverse operation. If this doesn't equal 0, then you know you've done something wrong. So 8y is 3y, and plus 3 minus 8, who knows? Not plus 5, it's minus 5. Good job. Now, I need to clear my 3y, so I'm going to subtract. I'm going to do the opposite of addition. And whatever I do to one side, I have to do to the other. That's kind of a commandment of math. And that makes 0. So 5y equals minus 5. Divide by 5, which is the inverse of multiplication. And we get y is minus 1. Let's try one more. All right, here we have an even more complex equation. Now, I could take my 2/5 over to here and solve it, or I could solve this and use cross multiplication. I'm going to start by solving this and using multiplication, and then we'll go back and try the other method. Do you remember when we learned how to add fractions? Who remembers the crossover rule? What would be my denominator? Jonathan. That's right, 5 times 2 is 10x. Very good. Now let's figure out the numerator. Who remembers how to do that? Right, Jennifer, I'm going to do this times this, which gives me 4x. And then I'm going to go 5 times x, and notice it's plus. And 5 times minus 4 is, 20's right, but what's my sign? 5 times minus 4, minus. Very good. And that equals 2/3. Now, let's ask the question, do I have a fraction on both sides of the equal sign? I do, don't I? So I can go ahead and use cross multiplication. Why? It's because I want to clear the fractions to rewrite the equation. Now, it looks daunting, but it really isn't. So let's start with 3, and let's do our big long one up here. Oh, you're right. We need to add those. Thank you, Adam. So it's 9x minus 20. Well, that's going to save us some work. Thanks, Adam. All right. Now, that even looks better. Let's try it. 3 times 9x is 27x. 3 times minus 20, put the calculators away, do it in your head. Right. Equals 2 times 10x, 20x. All right, very good. So, what am I going to do now? Okay, you want to take the 60. What's the opposite of subtracting 60? Correct. Now, why didn't I put it under there? Someone know? That's right. This has a variable, and this is just a number. So we can't add variables and numbers together. So, does this equal 0? Very good. So we have 27x equals 20x plus 60. I'm going to have to go over here. So let me rewrite that. It just goes to show that the boards are not always big enough. All right, what do I do now? Right, I subtract the 20x from both sides, because what you do to one side, you have to do to the other. So this equals 0. So I have 7x equals 60. And I divide both sides by 7. And I get 60 over 7. Now, can I reduce that? Does anybody know why I can't? I mean, I can change it to a mixed number. That's true. But why can't I reduce this any further? Does anybody know? That's right, Timothy. 7 is prime, isn't it? 60 has factors. This is a prime number, so I cannot reduce it anymore. All right, so remember today, cross multiplication, that's when I have one fraction on both sides of the equal sign, and the purpose is to clear the fractions and then rewrite the equation. See you next time.